one and all. Subject name is compiler design, and in this session we are going to discuss about the simplification of a type checking process. How the type checking process can be verified with the help of simple type check. So this we are going to take this concept as a brief overview of this notation. Now, what is a simple type checker? So in a simple language, we are going to define an identifier. So that is to be declared before using that identifier. So once you are going to use, in some of the languages we are going to define that one as a beginning. So that is the kind of the checking process, whether it is declared or not. And here the type checking is a translation scheme which synthesizes the type expression from the type of its sub-expressions. The expression of each type can be verified, and also sub of its expressions. Sub-expressions are also verified, and together it can be translated with an expression notation that is also verified with the type checking processes. We'll see with an example how this type checking is. So here it can be implemented with arrays, pointers, statements, and functions also. This type checking involved with arrays, pointers, statements, as well as now the specification of a simple type checker including the following things. One is simple language, type checking for expressions, type checking for statements, and type checking for functions. Type checking, we'll see one by one, each one by one. First one is a simple language. We have taken a grammar which generates some of the programs, and it contains non-terminals such as P, D, and D declarations, and E expressions, and P production. Suppose P derives D, E, P derives D, D derives declaration. So here, what is the type? It is to be determined. Here, identifier T. The T type is of type character, integer, or array, or pointer to some type. Pointer to some type. So this is called as T. And this translation scheme can be applied for the above rules with what is the type based on the type of identifier. So that is to be defined as semantic actions. That is to be defined as semantic actions. Now here, in case of identifier T, what is the type of this one? So that is to be determined by T dot type. That is to be determined by T dot type, and this can be entered into a symbol table notation or the language specific features which are used for that convenient purpose. A table, that is the entry that is to be inserted into this notation, that is called as. If you look at into the second one, character. So what is the type here? T type. That is to be action takes place. T dot type. And integer, T dot type integer, array type, pointer type. So what is of type T? It is a pointer type. What is of type T here? Array type. What is of type T? It is integer. What is T? It is character. So the type of each, it is a simple type. So that's why it is a simple language where we can determine easily, identify what type it is. So this type can be verified later if you write the another programmatic statement or instruction after passage of several lines of code, easily determined. Yes, this is a pointer of type T1, where T1 can be applied. It is a pointer type. So you can use it. Why? Because we have been, this is declared. Then we can use it in the following sequence. If at all, if it is not defined as that one declaration point, then it gives an error. Yes, the type is not defined. Next, type checking of expressions. So here expressions are also verified with the help of this type checking process. Here, what is the type? Character type, integer type, and sometimes entry identifier. Identifier also looked into the symbol table entries by using the method name lookup. This function lookup is to be used whether the what entry it is recorded in that one, and based on that one it retrieves the value and assign to this e dot type. And the mod function, it is verifies what is the e1 type. E1 dot type, it is an integer type. E2 type, integer type. Then the corresponding type is what type? It is an integer. Yes, expression is verified with 1. Else, error. That is type. In that way, type checking process can be done with the help of this expression. So that is mod. Another one is array, E1 array of E2. So what is E1 type? It is array type. E2 is integer. Then the corresponding type expected is of type E dot type is T, else error. And the pointer type, E1 dot type is a pointer, and else it is expected as type T, else returns error. So like that we are going to write a semantic actions for each of the types with type expressions, specifying that whether the expected type reaching the corresponding. And statements also we can define with this one. Here how that statements can be involved with the semantic actions. So what is the identifier type here and the corresponding expression type? If both are same, then the type is returns, else error. So if both are same, returns nothing, else error. And here if condition, if E then S1, that means the expression is of type. What is the expression? It may return true or false. That's why Boolean. And this is true. Based on that, S1 dot type will be executed. That means here evaluation of E dot type can be taken place. Then based on that, the type is executed, else error state. While control structure. So here expression E dot type. This is to be evaluated. Based on that, S1 dot type is to be executed repeatedly until conditions. Else the repetition of that is errors may occur. So like this we are going to write a semantic actions for each of the following rules and then corresponding actions. Functions are also we can define. Each of the functions. What is the function here A2? What is the type of E2 and type of E1? Both are E1 of E2 can be verified with this corresponding type, else error. So that's why here function is here. Suppose for example a function is defined. What is the function here? Double. And what is the another function? Function is the argument character. So double character. What is the return type you are expecting? So that is, it will verify whether this type, this expression of type and this argument of type, these two are evaluated and the combined expression result returns is of type same, correctly matching, X or not. That is to be verified in case of type checking of functions. So expressions, we know that an expression, while that is summary we have given each one, that is now one by one each we will discuss what is how the type checking of expressions, statements, functions. So type checking of state expressions, statements and function, given table wise brief overview. Now one by one we will discuss with that type checking process. Now the type checking process involves with the expression. Now here E is a synthesized attribute. E is a synthesized attribute. The type expression that is assigned to a type system which generates the expression that is E dot type. E dot type. So based on that we are going to. So here semantic rule says that constant represented by tokens, literal, and number have the type, character, integer respectively. What is the constants? Here literal it is a constant. Literal it is a constant. So these tokens, these type of rules which are defined in the grammar can be easily represented with a semantic rule such as type is character and the number it is an integer type. So here token literal is character type and number is integer type. So the semantic rule which is defined that E dot type. E dot type like this we are going to easily define for some of the rules which in the given production, the given grammar, we can easily identify and describe that one. Whereas expression kind of them identifiers, see here identifiers are to be obtained by using the method lookup id dot entry, and see here in the entry various identifiers, identifier 1, identifier 2, same they may give several names for these identifiers so that x, y, z identifiers may be available in the table. So each of the entries is to be represented with a number. So that number is to be that entry id dot entry. So this lookup function id dot entry can be verified through this function whether this is matching that identifier entry, what type it is. So that is to be verified by using E dot type. E dot type verified with the corresponding entry in the lookup by using the lookup function and the corresponding table. Whether this is exactly matched, then retrace that one, else it returns error. The function returns. Whereas the function mod operator can be also applied with the expression E1 mod E2. So for this, how the type checking process can be done. So the type can be verified first the expression E1 and what type it is. So that is to be represented as E1 dot type integer and E2 expected type E2 dot type also integer. If both are integer, that means E1 is integer and then it is a expected type eta type is integer. That means E1 dot type integer and E2 dot type it is integer, then integer. Integer means E dot type, left hand side E dot type it is an integer. E dot type it is an integer. So that's why here the type expression type can be verified and then by applying the mod operator the result which defines that expression is integer only, else if not any other results type obtained then it is error, type underscore error. This is called as type checking of expressions. For one expression like that array type also we can define with type checking of expression. So if E1 of E2, so in this what is E1? So the index specifies that here array. That means it is of type integer type. That means E2 is an integer type in which the elements are obtained are of type array of type E1. So index set entry is to be defined. So that's why here, what is the E1 of type? E1 dot type. It is an array. But array, what is E2? E2 contains integer type. Integer type of values, it holds some values, that index of values, array type. So E1 dot type is array. So array of some value. So that's why here type is, it is E1. This is E2. So the array of 100 maybe. So here what is the type of E1 here? Array type. And what is the type here? E2, integer type. So if this one, then it returns a type of array of integer, that is returns that value. Means it holds array type and the type is integer. Then what is the result? The type is T. That means if it is true, then returns else error will be written. Else error. Type is true. Whereas the postfix operator arrow which yields the object pointed to by its operand. Here the type of expression is the type of the point object which is pointed to the point. So here we are going to get one expression, that is E drive star E1. In this production, what is the type checking for E1 as well as E? So here the type checking process can be done for E1. So E1 dot type. E1 dot type. So here it is, what is the type of E1? It is a pointer type. So star indicates that pointer type expression. So that's why E1 dot type is a pointer type. Then pointer type, it returns what is the result after implementing this pointer type, returns the value. So that is to be determined with E dot type, expression E dot type. So if both are matched, then the result is displayed. Else, other than this any other, then we can get error. So this is the expression type checking process for array, that is array of individual values and pointers. Array that means E1 of E2, array of E1 which holds the array of values, and pointer holds of this array of, that is integer values E1. Pointer which pointing to the objects by its corresponding operand. So this pointer of the object pointed to the pointer, pointed to by the pointer, expression E can be verified. If both are matched, then it gives the corresponding result. Else, other than this, then errors will be. Type checking of statements can be implemented, like how the expressions in the same, we are going to use a language constructors, and here a basic type is assigned in order to make the special case. If error is detected in the statement, then the type is assigned to the type underscore. In the previous examples also we have seen type underscore error. So this error, if not matched, this is type underscore error. Previous also we have seen this one, this is type underscore if not result, not able to get the corresponding result. That means if the expression type is not, that means E1 is of type integer, E2 of type integer, then the corresponding E dot type result expected is integer only. In that case, it doesn't return anything. That means not error not returns. But other than this integer, any other, then it expression returns. That means whenever you type the type check for this expression E1 mod E2, E1 mod E2, then it returns a error notice. Then it returns error. So that is to be determined by type underscore error. So that is type underscore error. If error is detected with the statement, that means E1 type, E2 type, both are verified, and then operator is applied mod, and then result is returned the match exact, then that case, otherwise errors are to be. So there will be statements such as assignment statement, conditional statement, and while statements. These are all to be considered for type checking process. All the there are several other statements are also there. So we'll see that how this type checking process can be involved in case of conditional, while, assignment statement. Previously you have seen with the table. Now as each stepwise manner also we can see that information. The sequence of statements, that means more than one statement, those are separated by semicolon. Those are separated by semicolons. So here we have seen how the type checking of statements can be done. So this is a simple assignment statement, that means identifier equal to E. So in this one, what is the identifier type? ID dot type. And what is E dot type? Identifier type and identifier type. If both are reached to the same type, that means suppose if identifier type is integer, E dot type is integer, then it returns int. If else other than any other, then it returns error. That means here it returns void, doesn't return anything, then it doesn't return anything, then void. Else other than this, any other expected, then gives the error. So that's why that error is described as type underscore error. Type underscore error. Whereas a conditional statement, if E then S1. So here the expression E dot type. Expression is determined as E dot type. Suppose the expression is evaluated and the type is defined with any boolean value, that means true or false, then this type is expected is S dot type. That means expected type is S dot type. Else error. And while structure, implemented with while structure, while you do S1. That means this E type is to be evaluated expression boolean, then the corresponding S type is S1 dot type, else type underscore error. Sequence of statement, that is more than one statement. More than one statement. So how that is to be evaluated here, how the type checking can be done. S1 dot type is to be verified, as it doesn't return, it doesn't have anything void, and S2 dot it doesn't have void, then return is void. Combined S1 comma S2 S3 like that one. Then if the type S1, if the type S2, that means S1 dot type, S2 dot type, S3 dot type. Both are all are to be evaluated, and if it is a void, ST void, S3 also void, then expected is void. Other than this void, any other type returns, then else type underscore error. Other than this, any other returns, then type underscore error. This will be executed. So that is how the type checking process can be implemented with the help of these notations, that is semantic actions, which can be very easily identified and written a stepwise notation for each of the conditional, while, and sequence of the statements. First rule of the checkpoint here is left and right side of assignments have the same type. So here E derives some expression yes. So this type left side and right side evaluations of the assignments have the same type or not. And another rule says that based on that we are going to check the type checking. And second, and another rule says that conditional statements and while statements verify with Boolean statement whether they are reporting with the same type Boolean or not. Else, then errors are to be propagated with the corresponding rules. And only the sequence of statements which have the void, then only it returns. Any substatements are repeated, then verify the case if the result is void or not. Else, error batching occurs. So functions, application of a function to an argument can be captured by using the production f derives e of e. So here one expression, a application of one expression is to another can be specified by applying the rules such as association of type expression with a non-terminal t can be augmented by the following production and action to permit function types in the declarations. Now here, what is the type T1? So that is to be calculated as T1 type, T2, T2 type, T2 dash. Now here the domain and range corrected returns a type notation whether this type matches the T dot type or not. Whether this type matches the corresponding type or not. Then we can say that type checking of this two, or that means left side, right side of each of the function or the corresponding expression is to be verified, and they are one expression to another expression takes place and association also happen. So there is no problem. Else type underscore error is to be determined. Type underscore error is to be determined with that case. Functions. So here that is E1 of E2. So E2 is E1 of E2. It is what is the type of E2 and what is the type of E1. That means here type of E1 is some sequence of that is one set of values. E1 type is another. That is it is a domain type. It is a function type. So both are to be verified if they are reaching the same, else error. So in the inside another this, that means here the inside an expression by applying an E1 to E2 there must be a function s derives t. So E1 is defined with the type as s to t, and E2 is defined with one type, that is yes. Then the corresponding then it is range type t. Now E1 of E2 is t. That means here it holds good the domain set of values with the range set of values. Then that's why it is else type underscore. The E1 dot type is verified with the, that is the function is defined with the E1 of E2. So E2 dot type also verified. So here the correspondence with the two cases results with the t only. If at all if it returns t, then type checking of functions can be verified correctly. Else returns error, then it has that type checking of functions with return some error result. So E1 is failed expression with the E2. Suppose if you see with an example of this one, this function, a function is defined with argument double x and another one is character y. Now what is double x here? X and y. What is x type? Double. And what is y type? Character. So if you apply the expression for both the two cases, that means double and character and returns some type, the type expected is integer. Type expected is integer. Else error. Else return error. So it is which is the basic need of the for each of the. We can write as semantic actions. These are called as semantic actions, which are to be described for each of the expression and easily check whether they following the both. So like this, we are going to find out various semantic rules writing for the each of the production values like assignment statement, conditional statement, while statement, and sequence of statements S1, S2. Just write the just write the type for the corresponding expressions. Then left side verified, right side verified. If left side completed, then go for the left hand side of the expression. This is exactly matching that expression statement. Yes, then there is no problem with that one. So that's why the both types are to be evaluated in all the cases, and then finally returns the corresponding type. Else returns type error. So this is like this. There will be type checking of expressions, type checking for statements, type checking for functions. So expressions means simple expression, that is E1 mod E2 and E1 of it array and mod pointer, and statements, if condition, while condition, if condition, while assignment, conditional, while, and sequence of the statements. So, and here the main rule is where it strictly checks the type expression on the left hand side of the assignment and the right hand side of the assignment. If the right hand side of the assignment same as the left hand side of the assignment, that pointer types, that means here left hand side is, for example, in this T, right hand side is T1 derives T2. So this T1 type, T2 type, what is that type expression in this declaration? So this expression, what is the rules of this type expression with the corresponding non-terminal T, augment production with the left hand side, is to be declared with the right hand side, and this is to be verified. If both are matched, then it returns the corresponding type function, else error type underscore error. So E1 of E2 and E2 of it. So functions, the corresponding expression, E1 dot type, E2 dot type. So we are going to verify these corresponding statements as well as the functions, statements, if condition, while condition, and sequence of statements. So it's the same table representation also we are given as semantic rules with the stepwise. So just simply write the type of that variable. So in the while loop or in the condition, if condition state, individual assignment or if condition while. This is assignment statement. This is if condition. This is while statement, and this is sequence of statements. Sequence of statements. So we are going to verify whether this type exactly matching the identifier type. So ID equal to E. If ID equal to E, that means identifier equal to E dot type. Then left hand side S dot type is to be determined. Else, other than the types determined, then else errors type underscore error is to be. See. If expression then S1 indicates the type of E, that means E dot type. That means it may return either true or false. So that is Boolean. Then based on that S1 type is to be executed. Else one dot type is not executed. S dot type returns error. S dot returns error. So where is yes? So here yes is available here, left hand side. So this yes is to returns an error message other than this. Similarly for while structure also, we can implement as statement type checking process for while as a semantic rule. So while writing the semantic rule file while structure, what is suppose yes while E do S1. So what is the expression type E here? So E dot type, expression type evaluates, and then this returns either true or false. That means continuation of the loop takes place boolean. Then the step, that is S1, that is S1 dot type, both types are equivalent. Other types, it returns error. Otherwise, it returns error. That means S dot type returns what? S type underscore error. S dot type returns type underscore error. So this type checking process can be done individually with the help of each one as a semantic action. So we have to write the semantic action for each statement either as a separately within the curly brace, that is open brace and curly braces. Within the open brace, this is open curly brace and 10 curly brace, open curly closing brace and curly brace. Within this, we have to write the corresponding expression. So if id dot type is equal to E dot type. What is id here? This is the identifier. What is the type of id? So that is determined id dot type. And what is E here? That is also verified, equal to E dot type. So both types are verified. So this is the type checking process of assignment statement. Type checking process of assignment statement. Then the corresponding type is executed. That type is yes. So S is derives id equal to E. So here left hand side S dot type, it returns nothing. So that's why there is no error. Else case only type underscore error is to be written. Else case type underscore error. So like this, we are going to determine type expressions of type checking for functions, statements, individual expressions also. That is type character, it is individual type character, integer number. And lookup identifiers is to be verified based in the lookup entries method. And mod E1 mod E2, expression E1 of type integer, expression E2 of type integer, then it is an integer holds good. Else error. Whereas array type, that is what is the E2, that is integer type. So what is E1? Array type. So that is E1 dot type is array, which contains domain and range set of values, that is S comma T. Whereas E2 is type integer value. So this is to be holds good with the corresponding types S, else. Else report types, that is an error notation. And the pointer is E1 dot type is a pointer type notation. That's why it is returns error. It returns T in this case. E dot. So E is a left hand side, E dot type. Else errors are not to be. So in this way, we are going to give a semantic actions for type checking of individual statements such as, so we have to write a separate, so this belongs to this statement and this belongs to this rule belongs to this expression, this rule belongs to this semantic action, this rule belongs, that means these two statements are belongs, and this pointer belongs to these two expressions. So that means we have to write the semantic action for this is the two lines of code for the semantic action for the execution of this rule. And for this rule, we have to write these two lines of statements as semantic actions for this corresponding rules. Like this, we are going to write a separate semantic action rules, semantic actions for each of these specified values. So that means the rule may contain either mod operator, array, pointer, or identifier, numeral, literal, constant, or that is an expression type. Suppose it may contain simple language notations are also, or it may contain statements, individual statements, or sequence of statements, or if statement, or while statement, or any other structure statements. and functions with the domains and range set of values. So like this E1 of E2 we have seen with the various examples. Like this, the productions which contains various rules which are defined for each of that statement, function or expression. We have to write an equivalent set of semantic actions, and then we can easily check the type checking process for each of the defined entries. So that's why here we have seen with various notation. These are the simple type expression, that is array type, pointer type. Left hand side, right hand side, both are to be evaluated with the corresponding match type expected. Then returns the type, else it returns an error notation. So this is the main concept which is related to the type checking process involved in case of statements, expressions and functions. All the contents which are available from the book, that is compilers, principles, techniques, tools, that is written by three others, Alfred, Sithi, Ullman. Um, Next, we'll come up with a new topic, news with a new section. Thank you. Thank you, all of you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.